Okay, let's get started again. Again, this is the introduction to DevOps, right? And what I have in the agenda today is we're going to talk about software lifecycle development. We're going to look into what is actually DevOps, what are we studying, and what are the implications of studying DevOps? What does it mean, right, to study DevOps? And what are the benefits of DevOps? What are the tools that we need to use in DevOps? What are the cultures and the principles of DevOps? So that's going to be the agenda that we study today. Now, every philosophy or every methodology or every new concept, especially in engineering and in software, it has a methodology. The method of doing things. It's a way of doing things, or you call it the best practices of doing things. Right? It's that best practices that has been harnessed by always a group of organizations that come together and create a philosophy. This is how the best method or the best way, and it's always like a kind of a body of knowledgeable people that come together to put together a methodology. This is the best way to approach it. This is the best practice in the industry. So DevOps also has, or software development has a life cycle phases, right? We call it software development life cycle. It has a methodology. And these are the phases. First of all, it starts with requirements, right? Gathering the requirements. You gather the requirement. The requirement gathering involves what a customer actually needs. For example, we want to develop a software for Netflix, right? What does this, what are the things, what does Netflix need, right, in this software? Now, the product owner or the product manager goes in with a solution architect and they have an interview with Netflix. What do you really want us to do? So they'll come up with what they call a design requirement, right? And it's kind of more or less like a documentation. The requirement consists of what the needs of the customer, exactly the details of what it is, and they will break this down into detailed requirements and so on and so forth, and so on and so forth. But we are not studying how to gather requirements here. So I'm just telling you that the first thing that you do is requirements. Now, after the requirement, they come in and analyze these requirements, right? It goes through analysis phases, right? Let's analyze this. And who does that? Is the product owner, the product manager, the project manager, the business analyst, the CTO, right? Let's do an analysis and see exactly what this requirement entails. And if we know what the requirement entails, how do we design it, right? What's the system architects, right? The system architects involved here. How do we architect this new requirement? How do we build it, right? You come up with a design document, right? Then what's the UX? UX is the user interface. How is it going to look like, right? Let's design it. Now you have a UX expert that, for example, if you have, all of you have software running on your cell phone, right? All the software or applications running on your software is designed by a UX expert, right? That's another field. If you really want to get into software, that's another field that's really hard. To be a UX designer, right? That's a field that's really hard. If you want me to recommend another field for you, to be a UX or UI designer, it pays well. So a UX designer will sit down with a system architect after the design is done. Okay, this is how the interface is going to look at. These are the color selections that we're going to use on this application, right? Then it gets into development, right? Now the developers take over. You have the front-end developers, you have the back-end developers. Now get into the development, right? Development actually meaning writing the code that will bring up this software, right? After the software is being developed, it gets into testing. Now you have to test the code and make sure that the codes are running well and the software is actually running well. You have the solution architects, and the QA engineers, the testers, and the developers that come together and actually do the testing. Right? This could be divided, all right? The testing could be divided, depends on what kind of testing, regression test, or what kind of testing that you want to do, right? So after the testing is the deployment. The test is good. You have the development phase, you have the staging phase. Now you want to deploy it. Deploy it to where? You can deploy it to development environment, you can deploy it to staging environment, you can deploy it to actual production environment, right? So if you want to deploy it, right, you deploy it. And you have a data administrator, you have a DevOps engineer that will deal with the Kubernetes cluster. I talked about Kubernetes the other time. So you have a DevOps engineer and a database administrator that will take care of the database backend and do the configuration, and you get the software deployed. Then after the software is deployed, it doesn't stop there, right? This software has to be maintained, right? There are bugs that needs to be fixed in this software. So it goes through a maintenance down as depending on the environment that you deploy the software into, right? There could be a bug, right? If there's a bug in the software, it goes back to the developers. They will fix the bugs, and that's part of maintaining this. It doesn't stop there. There has to be a monitoring to see if this software is going through some kind of, for example, if you're deploying an application in a Kubernetes cluster, if you're using a pod dies so easily, it's very ephemeral. We'll get into that when we get into Kubernetes, right? You have to make sure that you have a monitoring tool that monitors your application and see what's going on. Another part of all this is the security part of it, right? The security part of it, which we are not going to cover, that's called DevSecOps, right? Development, security, and operation. That's another section altogether that we don't cover. It's a separate course altogether, right? Now, you have to be able to monitor your applications and see if there's what you call man in the middle of attack that wants to attack your software applications, or you have what you call DOS, delay of operational services, right? They can stop your applications. There are people that send what you call ransomware, right? That actually wants to attack your application. They make your application not to work, right? They can send a ransomware to a bank, right? If the bank application is not working, people are not able to withdraw money, you know what kind of chaos that would be, right? They can send it to like the recent one that happened on a pipeline. I can't remember the name of the company. The pipeline was an oil pipeline. They rendered the pipeline gas industry useless, right? So you need to have some kind of monitoring into your applications to see if there's any attack, any malicious attack, or man in the middle of attack. Now, if that happens, then you can quickly deploy what they call a WAF or any other security tool to be able to prevent that from happening. So that's part of maintenance also. So that's the life cycle of a software. Those are the phases that it goes through. So in the beginning, they use what they call the waterfall methodology. This is a waterfall methodology, actually. So what's the problem of this waterfall methodology? Now, what happens is this. You hire, I want to develop an application for Netflix, right? Now, I hire a whole bunch of people. I hire a product owner, product manager, business analyst. I also hire developers. I hire DevOps engineers, testers, QA engineers. So what's happening here then is this: while we're going to gather requirements, what do you think the system architect would do? What do you think a solution architect would do? What do you think a database administrator would do? All these people will be waiting until we go and get out the requirements, right? We got a requirement, they don't have anything to do, right? Then we come to do the analysis. Then only few people are involved in doing the analysis. So other people don't have anything to do, right? Look at the time wastage. Look at the money that's wasting. You're paying all these people. Then we get into development, right? The QA people are just waiting, right? Rubbing their thumb, waiting for you to finish development before they start testing, right? And so forth and so on and so forth. Get into deployment and the maintenance people, because these are different people with different skills. So this waterfall methodology is not very effective, right? So a body came around again and said, okay, this is not very effective. Let's get into another methodology. They call it the agile methodology, right? Agile methodology is, some of you are Scrum Masters here, so you probably know even more about agile methodology, whereby you have a plan, right? Plan is like gathering requirements, right? You have a requirement, you have a plan. Now, Netflix wants us to develop 50 features in their application, right? Instead of developing these 50 features at once, writing a monolithic application and going through requirement, going through design, going through all that phases that we went through, right? So agile methodology, what it does is it breaks down these features into sub features, right? 50 features, break it down into sprints. So we're going to do once the first sprint. Instead of developing 50 features, we're only developing 5 features, right? And we're going to finish these 5 features maybe in 10 working days, right? Then after 5 features, we take another feature, we call it sprint 2. We take 5 other features, right? We develop it, we call it sprint 2. So it goes through iterations, right? So you do the planning for sprint 1, design it, right? Develop it, test it, deploy it, review it, right? And launch it. You're done with phase 1, sprint 1. Then you go through iteration again. If anything was wrong with that, you do bug fixing. So you quickly deploy your application, your software, wherever it is. You go to define, they call it, you write an epic, you write stories. Those are basically the stories. Those are the requirements. They actually don't call it requirements, even though the solution architect would come up with a requirement. Once you have the requirement, then you use the requirement and write what is called an epic, or you create stories right from there. From your stories, that's what you're using in your sprint. Your stories guide those are some of the events that you're doing in your sprint. What are the features that we're developing? What are the stories that we're developing? And the stories are directly related to the needs of the customer, what the customer actually wants you to do to come up with that. And you go through this phase, plan it, design it, develop it, you test it, deploy it, review it, right? Then you go to another sprint. And after one sprint is done, you go do what they call retrospective, right? You go back and see, what did we do right? What did we do wrong? If there's anything that we missed, how can we improve it in the next sprint, right? How can you take the lessons learned in sprint 1 into sprint 2? And you keep improving the development cycle over and over and over. By the time you get to sprint 10, to create all the features, you have a whole lot of learning that you're taking from sprint 1, sprint 2, sprint 3 to sprint 10, and you have all the features developed, and you can actually hand off the application to Netflix, which is the original customer, right? So in this case, Rondustech is the software solution company that's developing this software and is developing it for Netflix. And Netflix, in this case, are looking for 50 features, which we extract from the requirement gathering, right? From these 50 features, right? We split it into iterations. Sprint 1, sprint 2, sprint 3, sprint, all the way to sprint 10. Then we develop these features one by one by one by one sprint. If you want to know more about agile methodology, I would also recommend you study Scrum. We have some Scrum Masters here. We'll create a course later on in this, not this class, we'll create a different course we have specialists, there are people that, like Louis is actually teaching Scrum right now. If you want more information about Scrum, Louis can help you. Abiola is also a Scrum Master as well. Okay, so this was the second methodology, right? After this methodology, well, agile methodology is great, is good. But when it comes to software development, right, the turning of the software, creating it, developing it and deploying it in a manual process did not really do justice, right? So the DevOps methodology came up. Actually, it's a philosophy, right? DevOps is used in combination with Agile. right? Some people will tell you that after Agile, then they come up with a DevOps methodology. No, most companies or all the companies here are still using Agile methodology in combinations with DevOps methodology, right? They marry each other. I don't care if it's self agile or it's lean agile, right? In either case, right, they still the DevOps process doesn't stand alone, right? You still use agile methodology for the planning, for the iterations, for the sprint. So this process will fall right into the agile methodology, and it really makes software development really effective and efficient, right? So let's get into software DevOps methodology. So DevOps methodology is more or less an automated way of doing things, of building software, right? Rather than the manual method of doing software development. It's automation. And that's what you're going to learn throughout this course, right? The first involves the planning, right? The planning. After the planning is done, you collect the requirements, you do the planning, then you write the codes. After the codes are built, then codes are written, then you do the build. After the build is done, you do testing, right? After the testing is done, you do packaging. Package it, then you do the release, right? Then you release it, it becomes an operation. It becomes operationable. So your application becomes operationable. You deploy it into the production environment, right? After you deploy it into operations.
I think
yes.
Some people are actually waiting outside to join.
Oh,
check. Abiola and
I need to remove this. Abiola, who else? So let me see. Do we have anyone else waiting? Yeah, it's just Abiola. Okay. I'm so sorry about that. I'm not monitoring this. I should keep it here just in case. Okay, so that's DevOps methodology in a nutshell, right? So I will get into details of this, right? This fits right into the Agile methodology. You use Agile and DevOps. So when you get into your job, you see that Agile processes and DevOps methodology, they intermarry each other, right? Right. They intermarry each other, but you need DevOps to understand DevOps to be able to use the Agile methodology, both of them together, right? You can become a Scrum Master, and being a Scrum Master, learning DevOps helps you a whole lot, because the developers, the DevOps themselves, all the language they're talking is pipeline, building, releasing, monitoring. That's the language that you hear in software development. And if you're a Scrum Master and you don't understand that language, you can still do your work, but for you to do your work effectively, you need to understand the language, right? So that's why it's important that you also learn DevOps methodology as well. So a little bit details into, right? This might look like an eye chart. Don't worry, I'm going to explain it. So the development in DevOps starts with what we call development, which is it requires the writing of the codes, right? And once the code is written, it has to go through a source code management software. In this case, is Git and GitHub, right? So what Git and GitHub does, it does versioning. When codes are written, this code has to be versioned. Right? You have version 1, version 2, version 3, so that if anything happens to version 2, you can roll back to version 1, right? You can select the version that you want to deploy or to build, right? So everything that you're doing in software has versioning. So source code management system, Git and GitHub helps you control the version. That's part of the development, right? So then you have what we call peer review. Peer review is all about developing, reviewing the code, right? reviewing the code, what is going on. You use some tools to help you with the code, right? That's peer review. It's all about using some kind of tools in the GitHub and pull your codes from GitHub. GitHub is a repository. I apologize. Can you see my screen? Can you hear me?
Yes, I can hear you.
Yes.
Just a second. Let me, I think my screen went out. Let me share it again. Okay. All right, can you see my screen now?
Yes.
Yes. Yes, sorry, my data turned off the power. Okay, so then you have the QA, right? QA is all about testing testing the application or the build. In this case, testing the build is not yet an application, it's called a build, right? You have a unit test case, so you use a unit test case that's written by developers to test if the codes that are written are doing what it's supposed to do. Then as you find bugs in the code, you do use some tools that does bug analysis, and you also can do security analysis. In this case, it's security, because security in this case is shifting left. You want to include security in everything that you do, but we're not studying DevSecOps, right? So I'm not talking about security. But you look at bugs and look at vulnerabilities in your code. If there are any vulnerabilities, right, you fix that, right? That's what QA does. Then we get into what they call pre-production. Pre-production is, all right, I want to deploy my application now. What do I need, right? I need high availabilities, right? When we get into AWS, you see what is meant by high availability, whereby you can, AWS has what they call availability zones. You have one in Oregon, you have one in California, you have one in South Africa, you have one all over, right? Where do I want to deploy my applications? So if I deploy it in Oregon, I'll probably also want to deploy it in California. Or if my customers are in South Africa, I want to deploy one there, or I want to create an edge in there, right? So that it helps with what we call latency, right? Sometimes you want to access your application and you see it takes a long time, longer than required period for you to access the application. That is latency, right? That's latency. You don't want your customer to experience latency. So you want to deploy your application closer to where your customers are. So if your customers are located in South Africa, you want to deploy your application closer to South Africa to take away that latency. So also you want to do what they call load balancing. We're talking about load balancing. Load balancing is directing traffic. How do you want your traffic to be directed, right? You have different availability zones. Then you have a load balancer that your application's traffic is coming in through, and then sends traffic to all the availability zones that you have, right? Then actually you can deploy your applications. What you do, put it in pre-production, you test it, it's working properly, then you can auto deploy it into production. In production is the same thing. You just replicate what you had here in the pre-production into production using your cloud-based internet services. You use your load balancer, you choose your availability zones, either in AWS cloud or GCP cloud or Azure cloud, which is the Microsoft cloud as well, okay? So that's what it's all about in a nutshell. I'll get back into the description of DevSecOps with the tool so you have a better understanding of it, okay? Let's get to the next slide. So this is another way of representing it, right? You have the source code. Now you have the tools now, right? The source code, what is in this source code? You have the original source code. Source code is, you can use Bitbucket, it's a tool. You can use GitHub, it's a tool as well for your source code. Azure repos, if you're using Azure also has what they call Azure repos. It's also where you can store your codes, right? Then you get into CI server, right? CI is continuous integration server, right? You have tools that you can use like Travis CI. Meanwhile, for the source code, we're going to use GitHub. We're not going to use Bitbucket, right? We'll use GitHub and Git, right? And for continuous integration server, we're going to use Jenkins, right? We're going to study Jenkins. But the other ones like Travis CI, right? You have Azure also has one. You have the Bamboo, you have TeamCity. So if you get into an organization and you hear about all this, they may not be using Jenkins, they may be using Travis. Once you study Jenkins, is the same thing. All of them follow the same integration processes. Okay, so what we're going to hone in is Jenkins, right? Then for testing, right? For testing, you have Meter, you have Cucumber, you have Scoop UI, and mostly testing. We will be using what we call SonarQube to do the testing. We write the test report. It's not listed in here, but we will be using SonarQube for our testing as a testing tool. Then we also have to, this is testing, we have to create an artifact, right? Creating an artifact means you're taking the code and actually building the software, right? You build, well, after you build, it's actually not called a software yet, it's called an artifact, right? So you're building an artifact, right? This artifact can be built using a tool called Maven, right? Then once you build it, you have to store this artifact somewhere, right? And you can store it in an artifactory, right? One of the artifactory is called JFrog, right? Or you can store it in the one that we're going to study called Nexus. Then there are deployment tools. You want to, after you've done it, you want to deploy it, right? There are some tools, a lot of tools that helps you with the deployment. One is Terraform. Terraform helps you with the deployment. Terraform is actually used for provisioning the infrastructure that you're going to use for the deployment, right? Then you have the Azure cloud and AWS cloud, all these clouds where you want to host your applications, right? You have Chef and Puppet. Chef and Puppet, some of the software that you use for deployment as well. We're not going to study all that, but is the same thing that you can use, is the same tool that you can use for deployment. Now, after the deployment, you want to monitor your application, right? Monitoring your application is a big deal, right? You have a lot of monitoring tools. In this class, we'll study Prometheus and Grafana. Then we also have Negus, you have Splunk, right? You have Amazon CloudWatch also that you can also use for monitoring your application. Here is another, if you're using DevSecOps, DevSecOps also has some tools that you can use. I mentioned SonarQube, Fortify, Tenable. These are all, you have JFrog X-Ray. X-Ray is another good one. You have Splunk, you have CashPoint, you have Nexus here. This Nexus, this should be a Nexus, not Nessus. It's called Nexus with an X. It is Nexus, right? So these are all some of the tools that you use in DevOps to accomplish what you need to accomplish, right? Okay. And I'm going to demonstrate some for you today to take a look at and how we actually use them. Okay, now that takes us to the question, what is DevOps, right? I put a sentence here that DevOps is a software development approach that emphasizes collaboration, communication, integration between software developers and IT operations teams. Okay, now listen, DevOps is not these tools that I just showed you. When you talk about DevOps, it's not these tools. DevOps is a philosophy. Right? a philosophy of software development. It's not the tools. The tools is actually what helps you. The tools are what you study, right? The elements of DevOps are the tools. But DevOps on its own is a philosophy, right? This philosophy is that there should be a collaboration in you developing a software. There should be a means of communication. There should be an integration, right? Not only between your teams, but between your tools. So these tools that you see here that I just showed you, these tools help you with integration. It helps you with communication. It helps you with collaboration. When we get into all this, you'll notice that these tools actually, apart from the human collaboration, right? The elements of collaboration also involve the tools itself, right? Communication, we talk about the traffic that needs to go through from one system to the other, and how you direct those traffic. It's all about collaboration, integration, and communication. So it's more or less a philosophy that helps you with the software development. So the goal of DevOps is to streamline the software development lifecycle from planning and development to deployment and maintenance by breaking down traditional silos between teams and creating a culture of shared responsibility, right? It's a culture of shared responsibility. So DevOps promotes the use of automation. That's what I was telling you about. The automation tool, the key automation tool, like I showed you here, is Jenkins. This is the one that we will be using. We call it a continuous integration tool. This is the main thing. So this is the main collaborator that brings all other tools together, right? So it promotes the use of automation and continuous integration, continuous deployment practices. When we started, there was a question that I addressed: what is continuous integration and what is continuous deployment? I told you, if you do the build and you can become a build and release engineer, that's continuous integration, right? Integrating all these tools together and actually building the artifact, right? After you build the artifact, you have to do what we call continuous deployment, right? You have to deploy the application. So it's continuous integration. You continuously integrate, you go back, integrate, go back from the cycle, you find a bug, you go back, fix the bug, put the bug, go back into planning, right? Develop, test, and deploy. Go back through the cycle. So that's why it is this. It's a cycle, right? Right. You plan, build the code, write the code, build, test it, package it, release it, deploy it, it becomes an operation, you monitor it, there's a problem, you go back to the original plan, right? Go back through the cycle again, rewrite the code where the bug was found, build it again, it goes through a cycle, right? And it's done in an automated fashion. It's done in an automated fashion. That's the keyword in DevOps, right? It also emphasizes the use of metrics and monitoring to enable the teams to measure performance and identify areas of improvement. So monitoring, like you see here, is a big one, because with monitoring, that's where you get the metrics, right? You can get metrics as a gauge, you can get it as a counter, right? What is it actually doing? When we get into Prometheus and Grafana, when we study Kubernetes, you see how we deploy Prometheus and Grafana, and actually see how actually you can actually use it to see how your CPUs are performing, and there's anything wrong with your application, you can react and go fix it, right? So that's monitoring. Okay. So let's get a little bit into the benefit of DevOps. It's good that we talk about this. These are all theories, right? It's theories that I'll send you this deck so you can study it. I want you to have a deep understanding of DevOps. What's the benefit of DevOps? DevOps has many benefits. Fast time to market, right? Prior to before DevOps was developed, right? It used to take between 14 months to 2 to 3 years for one application to be developed for a software, from gathering the requirements, doing the design requirements, writing the code, building the code, and deploying the code. But minimum of 14 months to about 2 to 3 years, if nothing goes wrong, right? Before a software is deployed as an application. Now, with DevOps, fast time to market. DevOps practices such as continuous integration, continuous delivery, and continuous deployment enable software development team to release new features and update faster and more frequently, reducing time to market, right? So if you have a product that you want to, you have a product, well, most all the software are called products, right? So when I refer a software as a product, I'm actually talking about actual software and application. So if you have a product that, let me beat. So if you have a software or a product that you want to develop, right? You don't have to start developing the entire features. You go back to the agile methodology, right? You take out the most viable product of most viable features and develop that features, right? Once you develop that features, you develop the features. You deploy the features, right? Then you go back in another iteration and get the next features and you develop it. So by this time, you already have your product in the market and you inform your customers the next phase of the features that you're going to develop, right? So while other organization is waiting to develop the entire thing, right, using the traditional method, you already use the DevOps methodology to get all the viable features out at first. Then you go back on iterative mode, right? Using your agile methodology, right? Dividing all your features into different sprints, you go back and develop new features and you keep using DevOps automated processes and get the thing to market as quickly as possible. So the first advantage is faster time to market. The other one is improved collaboration. DevOps promotes collaboration between software development and IT operation teams, resulting in a more cohesive and effective team. So you see, with DevOps, getting into the requirement gathering, getting into developing the actual code, getting into the deployment phase of it, building it and deployment, you have to have a collaboration going on with the IT team. So it helps that, and with that collaboration, right, you are able to create a software that is very highly effective and a very good quality. So that takes us to the next benefit, which is higher quality software. Because you are automating the testing, right? Testing is not done manually. You're doing a continuous integration because as you find a bug, you find problems, you're continuously integrating it and you're continuously delivering it. You're sure to have a reliable and more high quality software produced by the end of the day. Another one is better communication. DevOps emphasizes communication and collaboration between teams. It helps with communication. If you are able to communicate between your teams, you're able to create, for example, the team that I am in a application security team, right? We communicate every day on Slack. No one is allowed, we can work individually, but we look at the back of every team member, right? If you run into a blocker, right, you share information and I can block you and you can you can unblock me and I can unblock you. If there's something you do not know, specifically if you're trying to write a feature, maybe I'm looking for a situation where we use Ansible to deploy an application and I'm not really vested with Ansible. I have a teammate that knows Ansible, right? The teammate is going to help me, going to get me through, get that part of the application that I need to develop with Ansible, right? And do and write the Ansible code and do the configuration, right? So it helps that communication. So no one is blocked, right? You communicate very often so that you don't get blocked and let the application suffer. So that leads to a high quality software being produced and increased efficiency because you're using automation, you're streamlining the processes. It turns out to be, you have a better efficiency, improve customer satisfaction. Of course, if you're creating a high quality software and you're releasing it and you're having a communication with your customer all the time, it will lead to increase improve customer satisfaction. Then greater agility. DevOps enables teams to respond quickly, right? It allows to, because everything is automated, right? The testing is automated, continuous improvement is automated. So these are the benefit of DevOps, right? Someone might throw this into your interview question, right? It can ask you, what is DevOps? You really want to have a job in DevOps. You want to be a DevOps engineer, and can ask you, what is DevOps, right? Then you go into explaining DevOps, and it asks you, okay, what's the benefit of DevOps? You're a DevOps engineer. What are you going to help me with? What are you bringing to table, right? You can use this, the benefit of DevOps here, and start your interview process and answer your questions, right? Tell them about the benefits of DevOps, the fast time to market, how you can help, right, with your DevOps skills, how you can improve collaboration, how you can create a high quality software, how you can better communication within the DevOps community or your team, how you can actually make that communication happen, and how you improve the efficiency of the software and create greater agility within the team, right? So if they ask you that, prepare this so you can have it. The questions comes from anywhere, depending on the organization that you're trying to get hired into. So they may ask you this, so know the benefit of DevOps. It comes out quite often in interview questions, right? You can actually cram this, or you don't have to cram it, know what it is. By the time we get through all this, what we're going to get through, you'll see the benefit yourself. So you can talk through this without even cramming it and knowing what it is line by line, okay? So like I said, I mentioned to you earlier that DevOps is a culture, is a principle, right? So what are the principles and cultures of DevOps, right? First is automation, right? I've talked about automation. It's automation either in your build process, in your test unit, in your deployment. It's all about automation and all about continuous improvement. I told you, if you get the first viable features, you can develop them, right? Once you develop those features, you can go in and improve the features if you have a bug, right? It involves collaboration, right? Collaboration within the teammate, making sure that there's communication between the teams, right? And help the teams to work together and share knowledge. I told you about sharing of knowledge. If you run into problems with Ansible, a friend can help you with that, okay? Give me one quick second. Yeah, sorry about that. So the culture and principle, right, requires collaboration. Like I told you, you have to collaborate, and collaboration involves communication as well. Then agility is one of the principles. It's also the culture. It requires agile process. Well, agility is agile. Agile is agility, right? So the customer's need, you need to know their customer's need, right? The customer's needs requires you to apply advanced technologies to solve the problems, right? So it requires you to stay on top of technology. As a matter of fact, right? What I'm going to teach you in this class is a fundamental. It means you have to continuously learning. There are a lot of tools that are being developed every day. Even the tools that we're going to study in this class, there are improvement on those tools on a daily basis. So software, you have release 1, release 2. If you have an iPhone or Android, every time they ask you to update, right? Those are new release features that they're releasing, right? So even these tools that you learn, you need to also, right, learn new features that are being developed, right? So you have to be agile, know how to quickly respond to change in business requirements, your customers' needs, and technology advancement. You have to stay on top of it, right? So you have to continuously study, okay? So shared responsibilities, DevOps promotes a culture of shared responsibilities. So it's not only it's not only the developers, it's not only the operators or people in operations, it's not only the QA or the security teams, right? We all own it, right? It's total ownership, in other words, right? That's shared responsibilities. I own this product. If anything happens to this product, it's my fault. And being a DevOps engineer, you are a leader, right? Most people are looking up to you, right? There are some questions that will come onto you to help make decisions with, right? So they rely on you to get the pipeline going. If the pipeline is broken, if anything happens to the pipeline, they'll come to you for help, right? And you also go to them for help as well, things that you don't understand, right? So it's a shared responsibility, but is actually total, each and everyone takes total ownership of what is going on. Even if you're not in security and the security breach, it is also your responsibility, right? Infrastructure as a code. Infrastructure as a code is, you know what infrastructure is. A bridge is an infrastructure, right? A dam is an infrastructure. A road is an infrastructure. A software, right? You have infrastructures that you actually houses your software application. Your software runs on, right? Like your AWS, right? Those are infrastructures. Your EC2 instances that you have to build. Your network infrastructures that you have to build. Those are infrastructures. Your load balancer, all those are infrastructures, right? But instead of provisioning these infrastructures manually, you provision them as a code, right? You provision them as a code. That's what is called infrastructures as a code. You write a code, and the code actually creates your load balancer. You write a code, your code creates an EC2 instance. You write a code, and the code produces Lambda and whatever function that you want to use in AWS. That's what is called infrastructure as a code, right? So that's one of the culture. You don't manually, you're not required to manually provision or configure an infrastructure. You write a code, and that's when Terraform comes into play, and also Ansible comes into play. You can use Terraform or Ansible to actually write a code, and that's called infrastructure as a code. Then you have continuous delivery and continuous deployment, right? These are the ones that we've talked about. Continuous deployment is you continuously deploying your application, your software, as you get it through. And continuous delivery is, there's a difference between continuous deployment and continuous delivery, right? Continuous delivery is you stop when there's a test, you have to approve the deployment, right? They're all deployments, but someone has to give an approval after testing it, right? Continuous deployment is there's no testing, right? Everything is done in automation fashion. No one approves it to get into production. Once you test it and it's good, you have an automated way of testing and proving that the application is okay and it gets into production, right? So that's the two different. We'll get into continuous delivery and continuous deployment is part of what we're going to study in this course. So those are the DevOps cultures and principles that you need to know. If they want to ask you, if they ask you about the culture and principles of DevOps, you can take 1 or 2 or 3 from here and just explain automation, continuous improvement, collaboration, agility, shared responsibilities. And all those are core cultures and principles in DevOps that you need to know. Okay, we're still looking at the theories of DevOps. This is a particular example, right? This is an example of Netflix, DevOps Netflix example. Netflix is known for its ability to deliver high quality streaming content to millions of viewers. That's what they do, they stream videos, right? This is made possible through the use of DevOps practices, which allow them to quickly develop, test, deploy new features, and update to their streaming service. So when you're watching Netflix movies, right? They are not just, what they're doing is not just, think about the volume of movies that you have in Netflix. Think about how that is managed, right? Think about how that is deployed to you, and you're able to watch these movies without glitches, right? Now, that will sink in into the importance of DevOps. I know right now you've not even, you don't really know exactly, or you never thought about how does Netflix actually do this, right? How do they do this? The technology that goes into it. And if I tell you how many DevOps engineers work in Netflix to be able to get this automation to go on, you'll be surprised. There's a lot of technology behind what you see that you watch on a daily basis or weekly basis on Netflix. All those videos goes through a continuous integration. Some of them are microservices, or most of them are microservices, right? And they're deployed through the use of Kubernetes, through DevOps tools, like what we're going to study right now, right? So they use continuous integration, continuous deployment, they use microservices architecture, they use automation and monitoring, they use collaboration and communication. All the cultures about DevOps that we're talking about, right? That is what they're using right now. Take another company like PayPal, right? PayPal that you see a pay services application. By the end of the day, that's the interface, user interface that you interact with. But a number of software engineers and developers and solution architects that are behind that application, you have no clue, right? But we enjoy using it, right? Right. Think about a company like Walmart, right? How does Walmart handle the entire volume of data that they collect every day? How does or Amazon, how does their website, either Amazon website or Walmart website, they are all e-commerce, right? How do they work? How do they function, right? The intricacies in creating that software and maintaining, even when the software is created, and maintaining that software again alone, monitoring, ensuring that there's no attack, there's no middleman attack, there's no vulnerability, it takes a whole lot of effort, right? So that's why you're studying DevOps, right? Now, most companies right now that running an application, there's application they call monolithic applications. Monolithic applications are applications that develop from, if you have, for example, in a banking application, you have, what do you have? Saving account, checking account, you have services on how to pay and how to register. All those are services that, and in traditional ways, they used to write one code, right? One application code that handles the entire thing, and they deploy it, right? But that's not efficient. Now they're using what they call, that's called monolithic application. Now they're using what is called microservices. They divide or they split all those applications into what they call microservices. So each application, registration has its application. Saving has an application. Checking has an application. your welcome page that you see is probably an application by itself, and all that. So we divide all that into microservices application and bring it together as an application, so that if one of the services, microservices, is attacked, right, you are able to isolate the other microservices, so nothing happens to them, right? So you can isolate each and every one of them, and you can, and one part of maybe the sales part, if you're running an Amazon application and you have a sales like a Good Friday, and the purchasing application that you're running sparks up. Maybe there's a lot of registration, there's a lot of purchasing. You don't want to scale up the entire application, the whole microservices. You just want to scale up for efficiency, or only want to scale up just the service that it sparks up, right? What do? You monitor it automatically with Kubernetes. With a spike, it has what it call service recovery. It has what it call auto scaling, right? You would auto scale the port in Kubernetes language. We'll get into that, don't worry about it. And you can spike the port so that it accommodates all the traffic that is coming in. And that is software maintenance that you can use monitoring to do. And the tool you can use to monitor it is Grafana and Prometheus to see how your infrastructures are being used and how you can mitigate the problem that you may find in there. So that's the benefit of DevOps, and that's a particular example. I've talked about Netflix, I've talked about Amazon, I've talked about Walmart. Is the same thing. So all these companies are looking for DevOps engineers, right, to help them resolve those issues, to help them create new software. Some still use monolithic applications now. Some are trying to migrate from on-prem to cloud, right? On-prem to cloud. How do you migrate all the things that you were running? Because previously all your things were on-prem, your servers were on premises, right? On-prem means your servers, everything that you're doing are on premises, is in the organization. Now everything is in cloud now. How do you migrate your applications from on-prem to cloud, right? So you can also be hired as a DevOps engineer. In that case, you will be an infrastructure engineer. How do you take all the things that we're running on-prem, how do you migrate them to the cloud, right? That's another aspect that they might need your assistance with. Okay, so we've looked at some of the tools. We've looked at some of the tools already that are used in DevOps, but these are the tools that we will look into. We'll look into Git and GitHub. Git and GitHub is a tool that all the codes, it's a repository, right? It's more or less like a storage place where after writing the code, right? It's also what's called a source code versioning software, source code management software, right? It manages your source code. Source code is actually what the developers develop, right? Coding. When they code down, because they have to version it, they push it into GitHub, right? We'll study that. Then you have Jenkins. Jenkins is your CI tool, right? Continuous integration tool, right? Jenkins, it integrates all other tools that you see here. Jenkins would collect, I'll show you how to do this, but Jenkins is an integrated tool. Then Maven is the tool that you use in building the application. Once you build, it becomes an artifact, right? The artifact is pushed to Nexus. Nexus is another repository that you can store all your artifacts, right? Now, SonarQube is a tool that you use to create quality reports, right? The report that after this is built, right? SonarQube has to do a test and see if the build is okay. SonarQube has to test the code and make sure there's no vulnerability in the code. And once the report comes out okay, then it's good to go. Then I think I'm missing, okay, Nexus, you already have Nexus. Then you also have, this is Tomcat. Tomcat is used for deployments, right? You can deploy your monolithic applications through Tomcat, right? Deploy it, then the end user can use it, right? Prometheus and Grafana. Prometheus is what actually goes in if you're running, okay, let's go to Docker first. Docker, right? Docker is also a repository, is used to create containers, right? right? Docker is used to create containers. So we're going to start using what we call a VM, virtual machine, like AWS VM, right? Once we're done with AWS VM, right, then we get into containers, right? So Docker is used for containerization. That's what all you need to know right now. Then we have Kubernetes. Kubernetes is used for orchestration. After your application is being built, right, something has to orchestrate it. You want to scale it up, scale your application down. So Kubernetes, what we call Docker, you have Docker, you also have what we call Docker Hub. After Docker has created a container, it pushes the containers into Docker Hub. Then Kubernetes will pull the image from Docker Hub, right, and do what is called orchestration, orchestrate the application, meaning it keeps the application to be at your desired state. If you need 5 replications to your applications to become 5 replicas, Kubernetes will make sure that it maintains that state. If any pod dies, it will recreate itself. It also has what it call service recovery. Then you have Prometheus. Prometheus is what goes into your application and scrap the logs, the data, right? The logs, and send this data to what is called Grafana. Grafana is a visual tool that you use to visualize what is going on inside your Kubernetes cluster to see how your application is running, how efficient it is, how it's performing, and all that, right? So these are the tools that we're going to learn. Is there any other thing? I think I would dabble into Ansible. Ansible is also a tool that you use for automation. You can use Ansible for configuration. You can also use Ansible for provisioning. There's another tool that we may dabble into, is called Terraform. Terraform is actually used for provisioning of your tool, your infrastructures, right? So those are the tools that we will learn. So it's a whole lot. It's a whole lot that we need to learn. So, like I said, I need people that are hardworking. I need people that are hardworking. If you're hardworking, you'll succeed. Okay, the way to get started is to quit talking and begin doing. Right? That's Walt Disney. Walt Disney said that. With that, I don't want us to take a break. Let me show you real quick. I know we should take a break, but I won't let us take a break. We started late. Let's just complete this. I want to take you a little bit into, hold on, let me see. Yeah, that one already open for me. I want to summarize what I just told you, right? The tools that I just deliberated to you, right? So what happens usually, right? For example, you have, this is Rondustech technology, right? You have a guy, which is a developer, standing in here that develops the code. And by the way, this will be your morning devotion. When you get into interview, I would expect you guys to be able to know how to spell this out, right? It's going to be a morning devotion. I would expect you in your group to learn how to say this one by one, because in your interviews, you can use it to make your interview. Knowing this can make you or break you, right? So the developer developed the application, right? Once the developer develops an application, this application is pushed to GitHub, right? GitHub is a repository that holds the code, right? Now, the codes are being held there. And you have a Jenkins here. I told you Jenkins is an automation tool, right? It's a continuous integration tool. Jenkins will pull this code from GitHub, right, into Jenkins, right? Then Jenkins will signal Marvin that I have a code for you to build, right? Marvin will build the tool, will push this code, Jenkins will push the code to Marvin, and Marvin would build this code, right? So we have 2 tools here, Marvin and Ant, right? We're using Marvin in this class. We're not using Ant, right? So Marvin would do the build. I'm recording. So Marvin will do the build, right? The build can be a WAR file, an ER file, or a jar file. I will explain, right? A WAR file is a web application file, An EA file is an enterprise file. That is an enterprise application. Web application, this is a web application, like all the applications you have on the web, right? That's the kind of application. Enterprise application is just an enterprise application that you can use in your enterprise, right? For example, Boeing wants to develop an application for the employees to use. That's an enterprise application, right? Then a jar application is just a standalone application that you can use either on your phone or just a standalone application that you can use that solve just one problem or multiple problems, but it's a standalone problem. So what Jenkins does, Jenkins will push the code now, say, okay, now the codes are ready from GitHub. This would tell Marvin, right, now you can build the code. So codes will be transferred from GitHub to Jenkins, then Jenkins will push it to Marvin. After Marvin is done with the code, we have to do a quality test on the code to make sure that the build is okay. So SonarQube will do the build. SonarQube will do the testing, right? A test code report, right? So SonarQube is more or less like a QA, right? Like a QA does the testing and come up with a report. So, okay, this code is good. Once the code is good, is good, it's marked as okay. Now this code will be pushed to Nexus, right? Nexus is just a repository that holds the artifact, right? Now, once it's built, it's called an artifact. So it's a repository. Repository is just a storage place that you can keep your artifacts, right? So Nexus or JFrog, either you have just Nexus or JFrog, would store the code. So once this is stored, now it's time to deploy, right? So you can use for deployment, if you take this one out, take next Ansible out. Okay, you can leave Ansible here, right? You need application servers, right? The application servers can be Tomcat application servers. So let's put this here. Let me call this Tomcat, right? These are Tomcat servers. So these are Tomcat servers, right? App application servers, 1, 2, 3. So Ansible is a configuration tool. Ansible can also be used for deployment, right? In this case, I put Ansible here. I tell Jenkins, will tell Ansible, please, I need you to deploy this application. It's good to go. So the application will be deployed because I have so many end users that want to access my application. If I create one app server and this app server goes down, right, my end users will not be able to. So this server, this application, they will not be able to access it. So instead of having one app server, I create 3 app servers, right? I create 3 app servers so that if one application is, one app server is down, I still have my application in server 2. If server 2 is down or server 2 and server 1 is down, I still have application running in server 3. So Ansible does this coordination for me. It would deploy this application to these 3 servers. It's more complicated than this, right? I can just put a load balancer here, and the load balancer will distribute traffic to all these 3 servers, right? Application servers. Now, my end users are somewhere here, right? My end users are somewhere here, right? I have a lot of end users that would access these applications, right? These are my end users. My end users are here accessing these applications, right? All right. So these applications, if you do www.yahoo.com, right, the application servers will say, okay, I'm here, right? This is the content. This is what you requested, right? This is what you requested. These are the response. Whatever you want to. If you're a banking application, you do chessback.com. So you're able to access those applications. Amazon.com, you're able to access, right, those applications. But these applications are still under this development, DevOps development tool cycle, right? So what happens is I have a monitoring tool in here that goes into each of these application servers. So I have this monitoring tool. I can have what I call Prometheus that are in here in all these application servers. Or I can have New Relic. New Relic is another monitoring tool that monitors all this, monitors the CPU utilization, monitoring the storage utilization of all these servers. And see if anything goes wrong, it will report it to me. And I have a visualization tool that I'm looking at, monitoring to see what's going on. If my application is down, right, it will send an alert, right? The alert would then create what is called a ticket using Jira. Some of you have used Jira here. So it will automatically create a ticket, and the ticket will go back to the developers or the support team, right? And the support team would go back, get into the code, and go back through the process and fix the code and go back to redeploying, building it again, and redeploy it, fix that code, right? So the process continues, goes in a continuous fashion. Again, the developers will develop an application or also develop what we call a test case, right? And ship all this to the GitHub repository, push it to GitHub. Jenkins, a CI continuous tool, would pull that code, right? Send this code to Marvin. Marvin would create a build, right? After Marvin has created a build, Sonakit would do a test report to show that the build is okay. If the build is not okay, right? It will tell Jenkins that the build is not okay, and an alert will be sent to, it will show a failure, so it will break the entire process, automation process. And you have to go back and find out what the problem is and read the quality report and see what the problem is and go back and fix the problem. If Sonakit gives you the okay, right, then this artifact is now pushed to Nexus, which is a repository. Nexus will hold it, right? Once Nexus hold it and it's time for deployment, right, automatically Jenkins will say, okay, now it's time to deploy. Jenkins will send a signal to Ansible. Ansible, I have an application for you to deploy, right? So Ansible will now deploy this application, send it to App Server 1, App Server 2, or App Server 3, deploy it to these 3 applications, and the end user is able to access this application. While the servers are running, I am monitoring this server using New Relics, Prometheus, and Grafana to see if there's any problem going on with these servers. If there's any problem, I'll send an alert to the support, and the support will create a Jira ticket. Jira ticket will go back to the developers, and the process continues, right? So this is me using Ansible in this case to do the deployment. I can choose not to use Ansible, or I can use Ansible in combination with a Docker, right? Or I can totally eliminate Ansible from here, right? And I use Jenkins. Once I create the artifact, once I do the build, right? The build doesn't need to go to Nexus, right? I can also eliminate Ansible. I can choose to go directly to Docker, right? And create what is called an image in Docker. Now I'm creating a container now. I'm not using a VM anymore. When we get into containerization, I'll tell you the disadvantage of Docker. Container is lightweight. It's very portable. It's easy to use. And there are a lot of advantages. You can create microservices using a container, right? VM is heavyweight. You can also use VM to create microservices, but they are so heavy, they're not cost effective. They'll AWS or any cloud services will charge you arm and leg. So everybody's going to Docker because it's very good with microservices, right? So you create a container in Docker, and the image that you create in Docker, you push it to Docker Hub, and it becomes an image. Then you can pull these Docker images into Kubernetes, right? And create the application using Kubernetes to do the orchestration for you, right? Inside the Kubernetes, you can use Prometheus and Grafana to monitor what's going on inside your Kubernetes. And if there's anything happen, you can create an alert, create a Jira ticket, and it goes back to the developers and the cycle continues, right? So these are some of the things that we'll look in this entire setup is what is called a DevOps end-to-end automation pipeline, right? So we'll look into all this, we'll create this actually, and we'll show you how to create this. And this would be your major job if you take a job as a DevOps engineer, okay? That is where I want to stop today and take some questions. I know it's a lot. It's, like I said, is learning one of the Cameroon language. The first time you go through it, you probably will not understand anything. You go through it the second time, and Lewis is helping you translate that Cameroon language. By the time you go through 3-4 iterations, you start understanding what Lewis is talking about, right? So this is the first phase of you knowing what what DevOps is, right? We'll get into learning these tools, each of them one by one, and you get the light of it and you understand it better. So now I would unmute everyone, unmute yourself if you can, and let's take some questions. Let me see if I can unmute everyone. Are you able to unmute yourself?
Yes, please.
Okay, all right. Any question? Any comments? Is it understandable?
Hello, IT.
Yes.
Hi, this is Elvis speaking. Thank you very much for that sound presentation. Can you hear me well?
Yeah, I can hear you.
Okay. Quick question. The tools you mentioned, okay. Being honest with us, this is the first time I've ventured into DevOps, though I have an idea of those tools you mentioned. So, is it cast on stone that those are the tools you need to use, from Jenkins and the rest, Nexus? Do you have other alternatives, or are these the standard ones that are being used in the industry?
There are alternative tools that you can use. Let me go back to the first presentation. I think you missed the first part of the presentation.
Yeah, I'm afraid I did. Sorry.
Yeah, let me go back to it and show you. See, there are all these tools that are in the industry. They are competing against each other, but they're doing basically the same thing. For the source code, what we're using is GitHub, but you also have Bitbucket. You also have GitLab.
Yeah.
You also have GitLab, right? Azure has a repo as well, right? When it comes to CI servers, right? Continuous integration servers, you have Jenkins, which is the one that we're going to use. You also have Travis, you have Bamboo, you have TeamCity, right? And so on and so forth. In Maven, right, you also have JFrog Artifactory. Well, JFrog, this is just like the Artifactory here is, you can use JFrog to do a build, but you can use it as Nexus, as Artifactory, meaning Artifactory is a place that you store artifacts, right? So you can use JFrog in that place instead of using Nexus. But what we're going to study is JFrog, not what we're going to study is Nexus. As a matter of fact, Nexus is a product of JFrog, right? Yeah, Nexus is the product of JFrog. Yeah, so it's the same thing, right? So this is used for storing the artifact. Maven is used for building the artifact, right? And you have Puppet, and which is part of, it's like using Kubernetes. You have Puppet and Chev. You have Terraform that's used for provisioning your infrastructure. You can also use Ansible for provisioning infrastructures, and you can use Ansible for configuration as well. Then you have Nashus and Splunk. These are for monitoring. CloudWatch is for monitoring. These are different kinds of tools in the industries. It depends on what your organization does. In my organization, you allow the flexibility to use whichever tool. So they have all these tools in their toolbox, right? And you allow the flexibility to pick any of the tool that you are familiar with and work with it, right? For example, they have GitLab and GitHub. I'm not that familiar with GitLab, so I use GitHub, right? I don't use GitLab. I use GitLab. I go into GitLab because GitLab is just like GitHub, but there are some nuances in GitLab that I do not understand. I haven't had time to study it to understand the nuances, but like the documentation, if I have to do improvement in the documentation, is a requirement that we use GitLab because all the documentations are written, deposited in GitLab. So I still use GitLab. It functions exactly like GitHub, but GitLab has a CI/CD tool, right? It has, for example, it has Jenkins, something like Jenkins inside GitLab that you don't need Jenkins, right? But GitHub doesn't have it. With GitHub, you still need a CI tool like Jenkins, right? But GitHub has an integration. I haven't studied that integration tool, so I don't use it. So I usually use GitHub and Jenkins in my integration, right? So it's not set on stone that you have to use these ones that we are studying, but this tools that we are studying is going to give you an overview of what that tool is, what that tool does. For example, the Maven tool does a build. You can also use an Ant tool. Ant tool does a build the same way Maven does a build. It's only a different brand name from different companies. Any other question?
Yes. Another one. Just again, I know you said you get the slides or video to listen to. So are you saying for you to be a DevOps engineer, I mean, the requirement is more or less like knowing end to end, just like one would say a full stack software developer, which means you know the front end and the back end. Or can you, being a DevOps engineer, can you deal with, you know, a specific part of it, you know, or it must be the entire process?
No, you don't. As a matter of fact, when you get into industry, they probably will not even allow you to do the entire pipeline, right? Because the people that knows continuous integration, right? And there are some people that knows continuous delivery. Now, if you want to be on continuous delivery side, and most companies are doing what they call modern app applications now, with the use of containers, containerization. So you will be required to know how to create containers and how to do deployment using Kubernetes, right? So Docker Hub, Kubernetes, it will be your specialization, right? In the olden days, it was Tomcat, right? The use of Tomcat, you can use it to deploy monolithic applications, right? But everyone is moving away from Tomcat now for deployment and going into containerization and deployment. So you would need to know Kubernetes and Kubernetes. Now, if you know Kubernetes, the sky is your limit in this business, right? So like I said, you can just be a build and release engineer, but that's not what I pray for you guys. I pray for you guys to know everything. Now, why do I need you to know end to end? I need you to know end to end so that you can be flexible, right? You can get into any job market that you want. You can get into any job. You can become a site reliability engineer. You can be a DevOps engineer. You can be a solution architect. You can be an infrastructure engineer. You can be, so the choice is yours. When you have flexibility, when you have a choice to make a choice of what exactly you want to harness your skills with, it gives you flexibility when it comes to job, and you can do one part of the DevOps process and you say you don't really like it, you want to get into the deployment part of it, the choice is yours. So that's what I pray for you. That's what I really want you guys to gain by the end of this class.
Okay, if you don't mind, one more question before we leave. I'm sure this will help.
Yeah.
Is that okay?
Yeah, that's okay. Go ahead.
Okay. would I do it? Okay, I'll put it 2 in 1. I don't know if it's too early. So in terms of security for the apps, right? Where does that come in? Is it during containerization, or at what point do securing the app comes into play? That's one. Then the second one is in terms of notifying the developer of changes or possible changes, which you did mention the Jira. Again, being a tool that we're familiar with. As a DevOps engineer, would I be correct to say yes, you can use other tools and not necessarily just the Jira to report those changes or potential feature enhancement requests?
It doesn't need to be, like I said, all these tools that I list here is the one that we'll study. All these tools can be interchanged. You can use Confluence here to do the reporting if you need to. You can use any other tool here. It doesn't need to be Jira, right? It's just the one that I'm familiar with, or I'm familiar with Confluence as well. There's AWS actually has an automated way. What is it called? Yeah, I'm trying to forget my AWS word. Okay, AWS has an automated tool that you can use that actually does what Jira does here, and in a more systematic, more manageable form than Jira, right? So these are not set in stones. Now, I've forgotten another question. The first question that he asked
was where does security of the software app come into play, at what stage?
So what happens in DevOps, in software engineering, security has to move left. Security moving left, okay, this is the right part of it, right? We're shifting security left. Usually what happens is people were concerned about security when you do the deployments from here on, when you're doing the deployment, right? But you come to find out that even when you're writing the code, there are vulnerabilities. Your code are subject to vulnerabilities, right? So even when developers are developing a code, right, they have something, what they call lintel or lints. There's a software called lints that actually that actually goes into the code, right, and look at vulnerabilities in the code, right, and would help you correct those vulnerabilities, right? That's security moving left, right? That doesn't stop there. Now, there's a process whereby if you need to push your codes from GitHub, right, to Jenkins before it goes into Maven, it has to go through a scanning process, right? This will scan for vulnerabilities, will scan for any malicious attack, will scan for anything that would create any kind of code defects, right? That's security shifting left. Now, we're not doing DevSecOps. We're doing DevSecOps. I'll introduce you into all these tools. There are other tools that are called ZAP tools. There are tools that you can use to detect OWASP's top 10 security flaws, right? OWASP is an organization that look at all the securities and group the securities. And we have what we call top 10 securities that OWASP actually addresses. And you have softwares that are built to look at that. My company, F5 and Nginx, we have a WAF that you can actually deploy into either your Kubernetes cluster or your application directly that checks some of the vulnerabilities or some of the attacks, right? So there are tools that you can apply in between all this. You don't have to wait until you deploy your application in Kubernetes before you start looking at Kubernetes, right? What happens in Kubernetes cluster, right? What Prometheus does is it goes in and scrap the data, right? Scrap all the data inside there, right? The data comes in and you can monitor the data using your Grafana dashboard, right? And that helps. But security doesn't start here in Kubernetes when deploying. You can also put, before you download your image, before you download your image to Kubernetes cluster, you have to scan that image, right? You have to scan that image. That is in DevSecOps. Those that are DevSecOps. So what happens is if you're a DevOps engineer, you build your pipeline. A DevSecOps engineer will come in, right? Take your build and add security tools on top of this, right? So teaching DevSecOps is a different course altogether, right? From here, this as a CISO, there are other tools that you have to put in here to make it complete that will check for security, right? So security starts from the developers developing, right? And it goes through all through the entire phases of your software build. Okay, was there any other question? I think it was a three-part question that you asked.
No, yeah, I boxed the two together, but I mean, you did split them and it's fine.
All right. Yeah, thank you for those questions. So security is part of your best practices will be security, because they're going to ask you questions about best practices, which is best practices are security. Also, for example, when we get into Terraform, I may get into the use of Vault, which is use of Vault to store your secrets, right? In Kubernetes, you don't just put in your username and password in plain text, right? You have to use a Vault and store your secrets in the Vault, and whenever you need it, you call the secret and use them. So those are part of all securities. I'll get into best practices, but I'll not get into DevSecOps. If we get into DevSecOps, this will take us an entire year to cover the entire course. Any other questions?
Just to manage our expectations, I'm sure a couple of us might have this in mind. From your experience, how long realistically do you think, one would delve into DevOps, before you say, I think I'm ready to throw myself out in the public for a job?
So, like I said, right, what I do in this class, you do what I do, but you do better than what I do, right? For example, next we'll get into Linux commands, right? Linux commands are just Linux commands. If you practice Linux commands, right, ls commands, all the cmd commands, it's cmd commands. The secret of you knowing Linux commands is hands-on practicing learning those Linux commands, right? I don't care how many times you watch the video. I don't care how much time you listen, you read the notes. If you don't practice it, you would never be ready, right? So my proposal is, if you want to be ready for a job, what I show you, what I do in the video, what the labs that I present to you to do it, try to do it either in the group settings or individually, right? So that you gain deep knowledge into it, right? I don't expect you to go searching the internet and reading more, because what I'm going to pour into you in this class will keep you busy, right? Don't worry about going to internet to search for new product. If you can understand what I'm going to teach you here, you'll get it, right? You get it. But all I'm soliciting is hands-on. Practice it. Practice is not one of those classes that you learn the theory. It's a class that you do the hands-on. It is not a theoretical class. There are things that what I'm doing today, I'm going through the theoretical part of it. I want you to get the fundamentals of it, but it's a hands-on class. If you don't practice it, you would not know it. If you just watch the video and read the notes, it would help you go through the interview and you pass it. But when you get to a job, it's all hands-on, right? When you get to a job, they will expect that you know, and you have to actually practice it, put it into practice. So we'll do a lot of hands-on. What you see me do, I'll give you step-by-steps of what I'm doing. Just go ahead and follow the step-by-step. Do it over and over and over, and you'll gain mastery. And once you gain mastery, it becomes yours. Any other questions?
Yes, I have a question, Mr. IT.
Okay, go ahead, Louis.
Yeah, I don't know whether I am too fast, but I was taking down some notes when you were talking. When you presented the DevOps end-to-end automation architecture, you at the level of Ansible, we talk of deployment, and then we equally talk of 3 servers there that you, for example, that we have 3 servers that will be able to enable customers to connect to our applications, and then to our application. And you said we will learn more on load balancers, how it evenly distribute traffic through that. But then you mentioned something Tomcat, and then it was like 3 of these applications are under this Tomcat. Do you want to throw a light on it again, or
Okay.
too fast? Yeah.
So you have application servers. Application servers. Tomcat is an example of an application server.
Okay.
Now,
okay.
yeah, Tomcat is an example of an application server. So you can say this is Tomcat server, Tomcat server, Tomcat servers, right? So I put it here. So this represents Tomcat servers. So Tomcat servers are servers that you use to do the deployment, right? And you have some configuration that goes into it, right? There's configuration that goes into it that actually, once you type in the URL or you can type in the IP address, so 194.7.9.10.this. If you type in this and your application is exposed on port 8080, right? 8080, yeah, you should be able to access your application, right? After you do the configuration. Let me.
Sorry, maybe you
Right.
you are not sharing your screen, but I think
I'm not sharing my screen. Oh,
yeah.
I'm so
Thank
sorry.
you. Yeah, good. Thank you.
Hold on. Yeah, can you see my screen now?
Yes, sir.
Can you see the DevOps end-to-end automation?
Yes.
Okay, so these are the servers I'm talking about. So this Tomcat, this is a Tomcat server, this is a Tomcat server, this is a Tomcat server. Generally, they are called app servers, right? Because they're application servers. Because from here is your end user. This is an end user. End user A here, end user B. They are accessing this application through this app server, right? So if you have an IP address, right, an IP address, and you type in your IP address, and you're exposing this application on port 8080, I keep typing 80-80. Say you're exposing the application on port 8080. If you type this, this becomes your URL, which you can do a DNS resolution and give it a DNS name, right? If you resolve this, type this into your browser, you should be able to access this application, because this application is supposed, you've opened a port here and your port number is 8080, and this is the IP address of this server. Use this IP address and you're able to access your application in this server. And this server has configuration that goes into it, right? When we do a Tomcat server, you see how to configure a Tomcat server, and you should be able to access this application, right? So this is a general view. I'm just giving you a general. We'll get into all these tools, learn it, how to set it up and how to configure all these tools one by one. But this is just a high level overview of the tools that you will learn. Okay.
Thank you.
All right. I think we should have a hard stop at 10 o'clock. We have a class tomorrow, 7 o'clock in the morning, right? I'm not sure I've covered everything in the introduction. I'll look for the things that I'm missing and I'll share with us tomorrow. And tomorrow also, I want us to get into Linux operating system. We'll study Linux and Linux commands tomorrow. And I see that people are still waiting to be admitted to get into the class. I think I will go back and remove that. Since we know ourselves, the mission was so that we make sure that we don't invite someone into the class, someone doesn't get access. So we know the people that are here that have registered. I've not seen anyone that is foreign. I'll go back and see how I can remove that condition that I have to admit you into the class before you attend. That way we don't have people waiting on the outside without being able to attend the class. Okay, so that's where we're going to stop today. Reserve your questions. I'm going to post, if you've registered on Telegram, I'm going to post this note once I have the recording processed. I'll post the recording and I also post the PowerPoint that I shared with you guys today. And so this video will be live. You can go back and listen to it and we'll go from there. All right, so have a good night and talk to you tomorrow. Tomorrow morning by 7 o'clock Pacific time. London time, I don't know what time it is. Is it in London? So Elvis, you're on your own. So it's 7 o'clock in the morning Pacific time. Okay.
Thank you, Mr. IT. Bye, everyone.
All right, bye-bye.
Yeah,
Talk
this
to you
AM,
tomorrow.
right?
Okay.